Breaking news Friday afternoon about Artemis launch plans. Teams at Kennedy Space Center conducted initial inspections Friday to assess impacts from Hurricane Ian. There was no damage to Artemis flight hardware, and facilities are in good shape with only minor water intrusion identified in a few locations. Next, engineers will extend access platforms around the Space Launch System rocket inside the VAB to prepare for additional inspections and start preparation for the next launch attempt, including retesting the flight termination system. As teams complete post-storm recovery operations, NASA has determined it will focus Artemis 1 launch planning efforts on the launch period that opens November 12th and closes November 27th. Over the coming days, managers will assess the scope of work to perform while in the VAB and identify a specific date for the next launch attempt. Focusing efforts on the November launch period allows time for employees at Kennedy to address the needs of their families and homes after the storm and for teams to identify additional checkouts needed before returning to the pad for launch. NASA held a surprise news briefing, unveiling an exciting new concept to use a SpaceX Dragon capsule for raising the orbit of the Hubble Space Telescope and significantly extending its life. The idea will be studied over the next 6 months to determine its feasibility and risks. There is no firm plan to proceed with this mission, just the initiation of the study. Jared Isaacman, founder of the Polaris SpaceX Crew Mission Program, is involved in the proposal. Here are highlights from the audio-only news briefing.
I want to just tell you, I reassure that Hubble is amazingly successful. It's healthy. It's doing great science as we speak. In fact, we just put a picture out that it took as, in fact, DART impacted into Dimorphos. And it's in its 33rd year. And frankly, Hubble is more exciting than ever because it now is a complementary asset next to the James Webb Space Telescope in a different frequency range, in a different, with a different viewpoint, really complementary going forward. So, but we're here today to talk about the exciting potential for public-private collaboration focused on Hubble. And frankly, a few months ago, SpaceX approached NASA with the idea for a study whether a commercial crew could help reboost our Hubble spacecraft into a higher orbit, one that would extend its observational lifetime and frankly take something off the minds of the AA of science in later decades where kind of end-of-life scenarios need to be considered. Today, we're announcing that we have signed a Space Act agreement with SpaceX to produce a feasibility study of exactly that, as well as some other tools that may be coming to bear, really what the benefits and risks would be to having a private team help support one of NASA's science missions, do so, recognizing the importance of this mission, the risk that comes from it, but also the benefit from that interaction. You'll hear from others today with more details about the arrangement about Hubble, but I want to provide us a context of why we would sign an agreement like this. Of course, we have a large fleet of spacecraft within NASA's Science Mission Directorate of over 100 missions, 120 and counting, and every one of them is unique with its own goals, its own orbits, its own concerns. And as we go forward and we look at the emerging kind of commercial market, we always want to look at any and all possible opportunities to keep that fleet healthy and accomplish the science goal that NASA has. If private space industry might be able to help us with that, we want to know what the possibilities are, and we want to consider those. Commercial partnerships, we have learned, open the door for new and exciting opportunities for NASA's scientific exploration by offering new ideas and innovative ways to support them. NASA does not benefit from working solely in an echo chamber of ideas, frankly, but benefits from kind of exchanging those ideas openly and actively. It's important that we branch out and find ways to improve what we learn and really add new capabilities to our toolbox of options. I want to be absolutely clear. We're not making an announcement today that we'll definitely go forward with a plan like this, but we want to have a study to see really what would be feasible.
So it's absolutely exciting to think about the possibility of extending the life and capabilities of one of our greatest explorers. So Polaris is excited to assist in this study, and hopefully it does lead us down a path that ensures Hubble's ability to continue to serve science for decades into the future.
As a joint mission with the European Space Agency, Hubble has had more than 1.5 million observations to date and generated more than 19,000 peer-reviewed science papers, so arguably making Hubble arguably one of the most productive scientific instruments in history. In the past year alone, Hubble has released an image of the farthest individual star ever seen. The light of that star left over 12.9 billion years ago to reach us, and it's also observed the largest comet nucleus to date, a 4 billion-year-old relic from the early solar system. We will ensure that the feasibility study addresses Hubble safety throughout any sort of servicing or boosting scenarios that the study will consider. Thanks to the improvements of those past servicing missions, we expect Hubble will remain operational until the later part of this decade, if not into the next. Is that right now, the last projection we had in this past year was that we had a 50% probability of reentry in 2037.
So the main goal of the study is going to be a technical feasibility study. From a legal and liability point of view of what you're talking about, SpaceX currently docks Dragon to the International Space Station, which is just an incredible worldwide asset. So I think from a legal perspective, government perspective, we worked these type of things before, and we can get through those things. We may touch on them a little bit in the study, but the main goal of this study is just going to be technical.
Potential cost to reboost from, say, 335 to back to 375, 380 miles. Forgive me, I typically think kilometers. There's up to 600 kilometers. I think that's 375, 380 miles. And then the feasibility study will, in conversations with SpaceX and Polaris, we'll have some conversations about if there's potential enhancement capabilities that we can add on, but we haven't looked at anything specifically at this time.
What we did with shuttle, and servicing Hubble, one of the biggest kind of victories of really the agency as a whole, right? Bringing astronauts to bear and doing these amazing kind of changes of the instruments and all kinds of complexities. I just really want to make sure that everybody understands that as we start this study, I think we're starting at a point that is not at the level of sophistication kind of in our experience base that we were at the end of, the shuttle era. And I think it's just really making sure that we're all just really recognizing that as we look at safety of both assets, that we recognize, kind of that, each step that we, if the study comes out that way, if we decide to go forward, each step will be considered, and then each one of the lessons, even though it was possible in the past, will have to be regained, kind of with new technology, with new partnerships. In other words, don't expect what we did the first time. That is not the right kind of proof point to get started, right? Jared, or Jessica, you may want to add your own comments on this. I just really want to make sure that people, when somebody says servicing, it could mean all kinds of things.
So Hubble orbit was about between 560, 565 kilometers at the end of servicing mission 4, and we're now down to just under 535 kilometers. So we've dropped about 30 kilometers since 2009. Right now we have 3 gyros operating. So Hubble had been, during servicing mission, they had put in 6, 3 of which are what we call enhanced gyros. And it's those 3 enhanced gyros that are still operating, and we expect to operate for quite a while. The inclusion of the soft capture mechanism in servicing mission 4 certainly makes a mission like this much more feasible and easier to talk about. And it's going to be part of the feasibility study is to see how that adapter is useful and what kind of accommodations may have to be made, since even that design now is a little bit out of date of what the agency is using for docking mechanisms. But it certainly does provide an opportunity for a direct docking, we believe, without the need of a grapple arm necessarily.
And in terms of just Polaris in general, I mean, Polaris was announced earlier this year in February as kind of a partnership with SpaceX to undertake a series of tech development missions. The first of which is Polaris Dawn, which should launch towards the end of the first quarter of next year, and that has a number of components to it that are pretty important for, hopefully enabling and making life multiplanetary. So an EVA, an altitude component, new method of communication. But the idea was, at the time of the announcement, there will be a second mission, of which, it's certainly possible the study could result in this type of mission becoming the second Polaris program. And then the third is the first crewed launch of Starship, which certainly would be demonstrating quite a bit of new technology along the way.
Right. So the feasibility study, one of the things we'll look at is what is the maximum boost we could achieve. Preliminary assessment has been on the order of 40 to even, say, 70 kilometers of boost. Certainly, if we were to get back to 600 kilometers, that's essentially the altitude we were at in 1990 when the mission was launched. So you'd add easily 15 to perhaps 20 years of orbit life to the mission if you could achieve that altitude. In terms of the study, yes, we're looking at the idea of the feasibility study would be to look at, again, using commercial technology, commercial partners, those look at it from a boost opportunity, but also feasibility. What kinds of things might you be able to do with a servicing asset?
The Juno spacecraft has successfully completed its close flyby of Jupiter's ice-encrusted moon Europa, and images from its JunoCam camera are being processed by NASA and citizen scientists. The images were collected during a brief 2-hour window as the solar-powered craft raced past the fascinating moon at a relative velocity of about 15 miles per second. The distance was about 219 miles from Europa. Juno's entire set of instruments gathered data during the flyby, which was the closest since the Galileo spacecraft came within 218 miles in January 2000. Europa is the 6th largest moon in the solar system, slightly smaller than our moon. Scientists believe the salty ocean under its ice shell could support the conditions needed for life. Europa Clipper, currently being assembled at JPL, will launch in 2024. There were some interesting revelations about the experimental ion thruster on board the DART spacecraft at the post-impact news briefing on Monday. The thruster imparted potentially dangerous electrical current to the spacecraft during its test firing and was not used again during the mission. Here is how the situation was described to reporters.
You had some somewhat new technology on board this spacecraft as well, the solar-powered ion propulsion. I wanted to know if you could address how that went and also how this relates to future missions.
Oh, yeah, I love to talk about new technology on DART. Number one, our solar panels worked beautifully. That was a hair-raising moment for us early on in launch when we had to deploy them autonomously, and that worked wonderfully. They provided us as much power as we expected, and the whole deployment mechanism worked extremely well. And it will be extremely important for future missions to outer planets because of the mass savings you get with these rolled-up panels. So we thought the solar panels worked wonderfully. The Next-C engine, we did demonstrate it in flight for about 2 hours. We did fire it. It worked as expected. However, there was a little bit of interaction with the spacecraft as well that was not anticipated, and we have since then not fired the ion thruster as part of our miscontingency was actually firing it up again. But thank goodness we didn't have to do it.
Could you elaborate a little bit on how that interacted with the spacecraft?
Ed, do you want to talk about it?
Yeah, so early on in the Next-C development, as we were developing our interface document, we knew when you start it up, it has a reset mode where there's a little bit of arcing. And the reset mode was understood to introduce up to 25 amps of current that could go through the spacecraft structure. What was discovered after we launched and after we did this 2-hour demonstration, when we were looking at our telemetry, we saw some anomalies in our power system, and we investigated. And it led to an investigation using the engineering model of the Next-C thruster. And lo and behold, we found that there was not one but 2 different reset phenomenon that could occur. One was The second one was rare, and now it's understood, but it instead of introducing up to 25 amps, it introduced over 100 amps. And that was something that we were not tested to demonstrate that we could withstand that. And just from a risk perspective in trying to achieve the primary mission, which is tonight hitting the asteroid, we did not want to put that at risk. And so we talked with NASA and came up with a recommendation and a concurrence to just not fire it anymore. But as Lena had said, if we had missed, if we had a missed approach and the spacecraft was healthy, one of the options was we could have fired up, our whole risk posture has changed. If you missed it on approach, your risk posture changes. We could have fired it up, taken the risk coming over those couple, that 100 amps phenomenon again, and we would have fired it for about 8 days, and that would have put us on a trajectory that we would be coming back to the exact same asteroid 2 years later.
Yeah, and I'll just add that even in the future for NEXT-C missions, we don't see a problem with that. This could be accommodated. It was just something that wasn't not anticipated at the time when we put the thruster onto the spacecraft.
But ionized propulsion.
Yeah, but ion propulsion is extremely great for, especially if you want to go visit all these other asteroids, right? You can actually maneuver around them, and so we're really looking forward to it.
The thruster, the NEXT-C thruster is a fine thruster. It has great performance. It's just making sure that the interface between the thruster and the spacecraft are properly designed.